Simulation of control systems by mathematical tools. So aim of the experiment is to check the simulation of control systems of first order and second order system with a step input using the MATLAB simulation mathematical tools. So in this experiment we are going to use the MATLAB software and the blocks. So in this we are going to use the MATLAB Simulink models to see how the first order second order systems are giving the response. So in this we are going to see how we are going to use the Simulink model for the first order second order system. So in this previous experiments we are seeing the command window. We are going to write the program on that new model, and we are writing the command windows, and we are going to run the program, and we are seeing the response of the program. So in the Simulink model we are going for the Simulink model. So Simulink model is like this. If you open the Simulink model means the web page will be opened like this, and in this we are going to draw the Simulink model. In this experiment for the first order system we are going to give the step input, then one transfer function. We are going to, for that transfer function we are going to see the output. Then now we are going to see how to draw the Simulink models. So for taking the Simulink model, we are going to see the library browser. In this page, this is the library browser. So click the library browser. Here we can see the so many things that it's controlling blocks to use for the Simulink model. So in this we want to take the step input. So we are going to type the step. If you type the step and enter means you can see the step. You can see the step function block in this. See here, this is the step function input. So please right click this and add to the model of overtime. So I am name it as the model as the overtime. So you are including the step model into the your page. So here I am named it as a overtime. So in this file you can go and save your experiment name like overdamped first order system, underdamped, whatever you want that name you can file the name with and save it. So next your name you want the transfer function. So type transfer function. So searching for the transfer function. So see here first itself the transfer function. So right click it and add to the block of overlap. So here transfer function is added to the block. Then next you want the scope. The scope is for to see the output response. So scope. So enter the scope and searching for scope. So here is the your output scope. So right click and add to the block, your scope will be given. So see here you want to arrange like this. So you want to give the transfer function. So first you are going to see the first order transfer function. So your S terms will be in the first order. So see here want to join like this. By clicking, by having this arrow mark in the same direction, you want to connect the blocks of each blocks with the scope. So now you are going to save the diagram. You can see if you not save means there will be a star mark. So save the block diagram Simulink model and you run it. So you are seeing compiling. So if there will be error means it will not run. So here it's compiling. So after compiling you can see the scope. So it is the first step input for single transfer first order transfer function. See the scope. It will take some time to show the response curve. So here it's ready to show the scope. So this is your output for the step input. For first unit step input from the 1, it will take the output response. So it having the 1 by s plus 1. So from the 1 it's taking the step input. So this is the first order step input transfer function using the mathematical tools. So next sum we are going to see the second order system by using the transfer function s square 2s plus 25. So this is for second order system because your square term, S term having the S square term. So again same Simulink model, you are going to change the transfer function alone. To change the transfer function, you are going to right click the model. See block parameters. See in this we can change the parameters of the block. So here we are having the model of numerator with 25. So you want to write it as 25. So delete is at given 25 and denominator is s square plus 2s plus 25. So for s square you are having 1. For 2s, so for 2s you are having 2. Then for third term 25. So space 25. Then you can apply and you give OK means your transfer function will be changed as the 25 s square plus 2s plus 25. The transfer function will be changed. Now you see you have changed, so you want to save the function, otherwise it will show the star option on the file name which you have saved. So you want to again you want to save the function. Now you remove, you can see the star mark is removed. Then you want to run it. So it's ready to see the scope. Now you see the scope. So it is the under damped operation. So you are not at all having the stability of the operation of the control system. You are having the peak value and it will moving to the and it will going to the stable equilibrium condition. This is the second order system using under damped condition using the mathematical tools. Okay, wow. So third topic is we are going to check for the overdamped function. So we want to again want to change the block parameters. Here 25. Now for the overdamped we are giving the transfer function below us s square with 15s with 25. Apply, then OK. Your transfer function become the 25 by s square plus 15s 25. Again save the function and run it. It's ready. Now see the scope. So this will be the overdamped, but it will given you the function as a step input. So it will give the equally damped conditions. So it will answer the function. So next one is the undamped condition. So for the undamped we are giving 25. We are removing the s term. So removing without s term means you want to substitute as 0, apply and OK. So now your function become 25 by s square plus 25. Now save the function and run it. Now it's ready. Now see the scope. So it is the undamped. So your condition is undamped. So it is not will be given the stable operation. It will over going. The oscillations will be in the direction. So the oscillation will be there. That it will not attend any stable condition, equilibrium condition in stage. So it will be have the undamped oscillations. So this is the different types of systems, that is this is the simulation of control systems by the using the mathematical tools. Using the different blocks we are using the simulating tools for to control the systems. So like this we can use many systems. By in this you want to have the continuous model, then power grid. If you want any sources, you can see any input sources you want means it will get the many types of sources. So see the sources: clock input, workspace, clock counter, then pulse generator. So for any pulse giving for any equipment, for IGBT MOSFET you want to give the pulses means you can give the pulses from this block. So many blocks are available in the Simulink library browser. By using this we can easily execute the programs and you can see the response of the control systems. Thank you.